So in this session we will learn how to draw the cam profile for offset roller follower. So type of follower is offset roller. Offset is 12 millimeters towards the left. Base circle radius is 30 millimeters. Roller radius is 10 millimeters. Stroke length is 45. Outstroke angle is 90 degrees. And the motion of the follower during outstroke is simple harmonic motion. Outstroke is followed by dwell period of 45 degrees, which is in turn followed by return stroke, during which the cam rotates through 120 degree and the follower moves with uniform acceleration and retardation under the condition that acceleration is half of the retardation. Cam rotates counterclockwise. So the first step is to draw the displacement diagram. On y-axis we plot the follower displacement, and on x-axis we plot the cam rotation angle theta. So for y-axis, take the scale of 1:1. So we'll plot the follower displacement, which is 45 millimeters. So this is 45 millimeters. Draw one horizontal line parallel to the x-axis through that point. Then for x-axis, first stroke is outstroke, during which cam rotates through 90 degrees. So for outstroke we will take scale of 1 centimeter equals to 15 degrees. So 6 centimeter will give me 90 degrees. Okay. So this is theta O, which is 90 degrees. So I have taken the scale of 1 centimeter equals to 15 degrees. So this is 6 centimeters. So this is the first segment representing outstroke. Next is dwell of 45 degrees. For that, let us take two centimeters to represent 45 degree. So this segment represents the dwell period. Okay, and this angle is dwell angle theta d, 45 degrees. The dwell period is followed by return stroke of 120 degrees. So for that, take scale of 1 centimeter equals to 20 degrees. So that 6 centimeter will represent 120 degree. So this is 6 centimeters. 1 centimeter is 20 degrees. So 6 centimeter will represent 120 degrees. And this is the segment representing return stroke. Now in the next step, we will divide the outstroke and return stroke into 6 equal divisions each. So this is 6 centimeters. So one division for 1 centimeter. Now we will draw a line parallel to the y-axis through all these divisions. So this is first, second, number 3, number 4, number 5, and this is number 6. We'll repeat the procedure for return stroke and 12. Now I will number these divisions starting from the origin. So this is 0, 1, 2 up to 12. So 6 divisions for outstroke and 6 divisions for return stroke. Now outstroke takes place with simple harmonic motion. So for that, we will draw a semi-harmonic circle on y-axis, taking its diameter is equal to the stroke length of 45 millimeters. So we will locate the center at 22.5. So this will be the center of semi-harmonic circle. choose the radius. So this is the semi-harmonic circle. Now we have divided outstroke angle into 6 equal divisions. So we will divide the semi-harmonic circle into 6 equal divisions. So 180 divided by 6 is 30. The first one, second, third. Okay. And from this side, this will be first one, second and third. So I will mark these divisions on the semi-harmonic circle. This is one. Now we will number these divisions from bottom to top since the follower is rising during the outstroke with simple harmonic motion. So let us number this division as 1, 2, 3, 4, 5 and 6. Now I will join these division numbers to the center of the semi-harmonic circle using straight lines. To represent the segments. Now we will project these divisions on semi-harmonic circle across these division lines of the outstroke angle by drawing lines parallel to the x-axis. So this one, projection line number 1 will intersect the division line number 1 at 1 dash. Next is number 2. Next is number 3. Next is number 4. Next is number 5. Last one is 6. So 1 will intersect 1 at 1 dash. Projection line number 2 will intersect division line number 2 at 2 dash. 3 will intersect 3 at 3 dash. 4 with 4 at 4 dash. 5 with 5 at 5 dash and 6 with 6 at 6 dash. Next we draw a smooth freehand curve passing through all these points. So 0, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. This represents displacement diagram of the follower during outstroke when it is moving with simple harmonic motion. Now next is the dwell period during which follower is at rest at the topmost position. So its displacement is 0 during this period. So we get a straight line at topmost position for 0 displacement. And this point is 6 dash. Okay. Now for return stroke, follower is moving with uniform acceleration and retardation. And acceleration is half of the retardation. So say acceleration is half of the retardation. We know that V equals to U plus AT. Now during acceleration, so follower is at the topmost position and it starts moving down during the return stroke. So initial velocity of the follower before starting the return stroke is 0 and final velocity is also 0. After the end of the return stroke, it is at rest at the bottommost position. and during some period of time it is accelerating, and at the end of acceleration it will gain the velocity v, and after that it will retard. So during acceleration initial velocity is 0, so we can write this equation as v is equals to f1 t1, where f1 is the acceleration and t1 is the corresponding time. So t1 is v upon f1. Let us call this as equation number 1. Similarly, during retardation final velocity is 0 and initial velocity is v minus, because it is retardation, f2 is the magnitude of retardation and t2 is the corresponding time period. So from this what I can write t2 is equals to v upon f2. Okay, now this is also equals to v upon twice f1. From this, acceleration is half of the retardation, so retardation is 2 times the acceleration. So t2 is equals to v upon f1 is nothing but t1, so 1 half t1, or t1 is twice t2. Okay, so we know that in the displacement diagram x-axis represents cam rotation angle theta or the time. So we can write for this theta r1 is 2 times theta r2. The angle turned by the cam during acceleration period is 2 times the angle turned by the cam during retardation period, and we know that total angle is theta r1 plus theta r2 is the total angle theta r turned during return stroke. So substituting this here we get twice theta r2 plus theta r2 equals to theta r. So 3 times theta r2 is theta r. So theta r2 is 1/3 of the total return stroke angle, and total return stroke angle is 120 degrees. It is 120 degrees. So we get theta r2 as 120 divided by 3, 40 degrees, and theta r1 is 120 minus 40, it is 80 degrees. To find out the corresponding displacements during acceleration and retardation, the displacement of the follower, we use this equation. Now during acceleration, say s1 is the displacement, initial velocity is 0, so half magnitude of acceleration and the corresponding time square. Call this as equation number 2. Okay, now during retardation we have s2 is equals to, say s2 is the displacement of the follower during retardation. Initial velocity is v, corresponding time, now it is retardation, so minus half magnitude of retardation and the square of corresponding time. Now we know that v is equals to, for v we can write f2 into t2, correct, for v. So this becomes f2 t2 square minus half f2 t2 square. So 1 minus half is half f2 into t2 square. Now f2 is 2 times f1, 2 times f1, it is given. So s2 is equals to half 2 times f1, and t2 is 1/2 of t1. So 1/2 of t1 square. So 2 goes, So F1 T1 square into 1 upon 4. Now from equation 2, F1 T1 square is 2 times S1. So this is equals to 1 4 2 times S1. So 2 2 are 4. So finally we have S2 is equals to 1 half of S1, or what we can write, S1 is equals to 2 times S2. Now if S is the total displacement of the follower during return stroke, which can be divided into two parts, displacement during acceleration and displacement during retardation, but we have S1 2 times S2, so this is 3 times S2. So S2 is 1/3 of total displacement of the follower, and that is equals to 45 millimeters. Stroke length is given. So S2 is equals to 15 mm, and S1 is 45 minus 15 is 30 millimeters. So let us note down this. We have theta R1 80 and theta R2 40. So theta R1 80 and theta R2 40. Next we have S1 30 and S2 15. So S1 30 and S2 15 millimeters. Okay. Now for return stroke, we have taken scale of 1 centimeter equals to 20 degrees. So first is acceleration period of 80 degrees. So 20, 20, 20, 20, 80. So this is theta R1, 80 degrees, during which the follower is accelerating. And the remaining period, theta R2 is 40 degrees, during which the follower retards. It is 40 degrees. We have taken scale of 1 centimeter equals to 20 degrees. 1 division represents 20 degrees. So 20, 20, 40 degrees. This represents theta R2, and total is the return stroke angle theta R 120 degrees. Now we will divide this line number 10, which is separating the accelerating period and retardation period, into same number of parts as that of the return stroke angle. So we will divide this line into 6 equal divisions. Total is 45 millimeters. So line number 10. So 45 divided by 6 is 7.5. So this is 15, 30 and 45. Now half of this is 7.5. So this is 7.5. This is 7.5. Now we will number these divisions from top to the bottom, because this is return stroke. Follower is moving from topmost position to the lowermost position. So this is 6. This is 7, 8, 9, 10. This one is 11, and last division which overlaps with point number 10 is 12. Now let us draw the projection lines. Now S1 is 30 millimeters. Displacement during which the follower is accelerating is 30 millimeters. So 2 divisions 15, 4 divisions 13. So point number 10, this is S1, 30 millimeters, and S2 is 15, so 7.5, 7.5, 15. Displacement during the retardation period of the follower. So now we'll draw the projection lines from this end. This line joining point number 7 will intersect this division line number 7 at 7 dash. line joining point number 8 will intersect this division line number 8 at 8 dash. Similarly, this will intersect 9 at 9 dash. The last one for acceleration period will intersect 10 at 10 dash. Now for retardation, we'll change the direction. So this will intersect 10 at 10 dash. This will intersect 11, division line number 11 at 11 dash, and 12 at 12 dash, which will overlap point number 12. Now we will draw a free smooth curve passing through all these points, and that will be the displacement diagram during written stroke. So this represents the displacement diagram of the follower during written stroke when it is moving with uniform acceleration and retardation, and acceleration is half of the retardation. Okay. Now next we will draw the cam profile for this. So the first step is to draw the base circle. Base circle radius is 30 millimeters. So this is base circle. (30mm). Next is to draw the prime circle. Prime circle radius is base circle radius plus roller radius. So 30 plus 10 is 40. With the same center, we draw the prime circle. Draw the vertical center line of these circles. This is the center of rotation of cam. Now offset of the follower is given as 12 millimeters to the left. So 12 mm to the left. 10 plus 2 is 12. I will draw one line parallel to this to represent the line of action of the follower. So this is the line of action of the follower. Now let us draw the follower. A roller center will exactly lie at the point of intersection of its line of action and the prime circle. So this will be the center of roller, and radius of roller is 10 millimeters. So this is the roller. We'll draw it again. So this is the roller at the lowermost position. You can of course draw the follower, because due to space limitations I will not draw. So this is the roller follower. Now next we will join the center of cam with the roller center using a straight line, and this will be the base for plotting the angles. Now the cam rotation is given in counterclockwise sense, so we will divide the prime circle in opposite direction, that is in clockwise direction, in the same manner as that of x-axis in the displacement diagram. Okay, now in the displacement diagram we have divided x-axis into three segments: outstroke, dwell and return stroke. So here we will divide the prime circle into same number of segments. In the direction opposite to the direction of rotation of cam. Cam is rotating counterclockwise, so we will divide the prime circle in clockwise sense, starting from this line. First angle is outstroke angle of 90 degrees. So this is 90 degrees. So theta O. Next is dwell period of 45 degrees. So 45, theta D, which is followed by return stroke of 120 degrees. Theta R, return stroke angle. Sorry. Now next, we will divide the outstroke angle into 6 equal divisions, because we have done that in the displacement diagram. So 90 degrees, 90 divided by 6 is 15. So each division will be of 15 degrees. So this will be first, second, third, fourth, fifth and sixth. Let us mark these divisions on the prime circle. This is first one, second, third, fourth, fifth and this is sixth. We'll number these divisions starting from 0. 0 is the roller center. So division number 1, 2, 3, 4, 5 and 6. Now we will do the same thing with the return stroke. We have divided the return stroke angle into 6 equal divisions. So 120 divided by 6 is 20 degrees. So each division of 20 degrees. First, second, 60, 80, 100 and 120. We'll mark these divisions on the prime circle. First, 2, this is 3, this is 4, 5 and 6. We'll number these divisions. So this is the start of dwell 6, end of dwell is also 6. Next division 7, 8, 9, 10, 11 and 12. One thing you will remember, that you will divide the prime circle in the direction opposite to the direction of rotation of cam. In this case, cam is rotating counterclockwise, so we have divided this prime circle in clockwise sense. Now after this, let us draw the offset circle. Offset is 12 millimeters towards left. So take radius of 12. So this is the opposite circle having radius equals to the opposite distance of the follower. In this case it is 12 millimeters to the left. So with radius of 12 millimeters I have drawn the circle. Now in the next step we will draw the line of action of the followers passing through all the division numbers on the prime circle. Now going by the law of kinematic inversion, cam is rotating counterclockwise, and if you hold the cam stationary, follower will rotate clockwise, and as the follower rotates clockwise, this line of action of the follower will roll over this opposite circle in that direction. So we'll draw the line of action of the follower at all the instances passing through these division numbers and tangent to the opposite circle in clockwise sense. So this is first one. This is second. Third. Fourth. Five. Six. Okay. Repeat the same thing for written stroke. This is point number 6. The displacement is 4 millimeters. So on this line of action which is passing through instance number 1, we'll plot that distance of 4 millimeters. This is my point. Then at instance number 2, the displacement is 7 millimeters. So we'll plot the distance here. It is 12, not 7. So this is 12. This is my point. At instance number 3, it is this much. We'll extend this line. So this is the point. Now at instance number 4, yes, this is the point. And instance number 5, this is the point. And at instance number 6, it is 45. So this is my point. Now I will number these points 6 to 6 dash. We have plotted these distances. 5 to 5 dash, 4 to 4 dash, 3 to 3 dash, 2 to 2 dash, and 1 to 1 dash. These are the positions of trace point, that is center of the roller. Similarly, we will plot the displacements for the written stroke. So I have plotted the displacement for written stroke as well from the displacement diagram in the similar manner. So when the follower is at this instant, at instance number 1, its displacement is 1 to 1 dash. When it is at 2, its displacement is 2 to 2 dash. When it is at 3, its displacement is 3 to 3 dash. When it is at 4, its displacement is 4 to 4 dash, and so on. Okay. Now these are the positions of trace point, that is center of the roller, So at all these instances we will draw the roller. Radius of roller is 10 millimeters. So I have taken the radius as 10. Now at all these positions of trace point we will draw the roller. Sorry. This first one. This is second. This is third. This is fourth. This is fifth one. And this is sixth one. So we'll repeat the procedure, or we'll draw the roller positions for the return stroke also. These are the rollers at all the instances during return stroke also. Now in the last step we will draw a smooth curve tangent to all these rollers to get the cam profile. Start from the roller number 0. You will notice roller number 0 and roller number 12 are touching the base circle. They must touch the base circle. Let us draw a smooth tangential curve. Okay. Now during dwell period, this is the last dwell at the lowermost position. The cam profile must be the perfect circular arc. And this is also the dwell period, 6 dash to 6 dash. And that should be also a circular arc with its center at the center of rotation of cam. So we draw this curve using compass. So this is the cam profile for the follower, offset roller follower moving with simple harmonic motion during outstroke and uniform acceleration and retardation during return stroke. Thank you.